So welcome to this computer engineering drawing subject. So we'll see how to solve the problems on isometric projections. So here you have a problem. A hexagonal pyramid of a side of a base 20 mm and height 60 mm rests on center on the center of a top face of a square block of a side 70 mm and thickness 20 mm. So draw the isometric projections of the combination of solids. So now it is what a combination of two objects here. One is hexagonal pyramid. So another one, it is a square block. Okay. Now let us look over the dimensions. Hexagonal pyramid, it is of a base side 20 mm and it has a height of 60 mm. Next, about the square block, dimensions are 70 mm, it is a square, and thickness is 20 mm. So now these two are placed coaxially. Okay? So that means top face of the square block and the base of the hexagonal pyramid is placed coaxially. That means so center of the top face of a square block, okay, is coaxial with the axis of a hexagonal pyramid. Now just observe. So let us draw first a square block here. It is what a square block. Okay. So now this is what a base object. So it has a dimensions 70 mm. It is a dimension of 70 mm and the thickness it is 20 mm. Over this one, a hexagonal pyramid is going to be placed. So now this is what a combination of hexagonal pyramid and this one is what a square block. So you need to draw its isometric projection. Okay. Now let us see the solution, manual solution of this problem. So now let us first construct a square block of a side 70 mm and thickness 20 mm. So anyway, we just go for referencing a one corner point here. Now I am going to make a corner point. So from this corner point, you just draw a thick line for 7 units. So as you are going to draw the isometric projections. Okay. So let us go for 7 blocks. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. Similarly, on left side, you just draw 7 units. You just complete a line covering 7 units. 2, 3, 4, 5, 6, 7. So now thickness of the block is 20 mm. You just draw a line covering 2 vertical units here. So once you've done it, complete the top surface. Now let us draw vertical edges here. Let us draw vertical edges. Now let us complete the top surface visible edges are thicker here. Top surface visible edges as a thicker. let us draw these back side edges as thin, because some of portion is going to be hidden. It is going to be hidden, or you can say it is a height. So we can cover visible edges as a thick edges and hidden edges as a thin edges. Okay? Now this is what a completion of a square block. So now we need to draw the hexagon with isometric scale. So now let us draw a hexagon here with isometric scale. So now size of the hexagon is side 20 mm. Okay. So if you convert that one with isometric scale, that is what isometric projection scale. So 1 unit equal to, that means 10 . So here 10 mm equal to 8.163 mm in isometric projection. Okay, it is 8.163 mm in isometric projection. So now it is a 20 mm side. It is a 20 mm side. So you just multiply 2 into 8.163. Okay, so approximately we need 16.326 mm as a one side length or one base edge length. Okay, so now to complete this one, what I will do, I will going to draw a circle of 16.32 mm. So then I am going to construct the hexagon by using the arc method. Now let us take 16 point. Okay. So what I'll do, I'm going to draw a circle here. Okay. And along that one, I'm going to construct vertical lines, vertical center lines, and horizontal center lines. Center line means we need to go for long dash, short dash. The actual procedure is first you need to construct a center line, then you need to draw the circle. So now I'm going to construct a hexagon here. Somewhere we made a mistake. There. Okay. Okay. So from here we need to draw it. Okay. That is what we got wrong. Okay. So you need to construct with the help of quadrant circle, quadrant points. Now let us see what I done. I took a same radius of the circle. From right side quadrant point I drawn two arc, and from left side quadrant point I drawn a two arc. One is on upper side, another one is on a lower side. Okay. So now I am going to connect the points to obtain a hexagon shape. So now you've got a center point of this hexagon. So you can measure with the help of scale. So how much distance you are getting is around about 2 times of the base edges in horizontal direction. So here in vertical directions, you need to check out it. It is about more than radius. That is about 1 point. You are getting 14 mm on top side, 14 mm on down side. Okay. Or else you can just construct a rectangular block covering all corners of a hexagon. Okay. Now let us go to a point 1 here. You got a point 2, point 3, point 4. No. Identify the center point of this square block first. So it is 1, 2, 3, 4, 5, 6, 7. Let us mark 3.5. Sorry. 1, 2, 3, 4, 5, 6, 7. 3.5. Now construct center lines with a very thin. Let us put some light pressure over here. Now keeping this as a center point, you can just measure the distances. Okay, so I'll measure the distance from center point. So now this corner, okay, is equal to radius. What I'll do, we'll keep here center point. I'll mark one corner point and I'll mark another corner point. Okay. So now you measure the distance. So here from this hexagon, measure the distance, this much distance. Okay. So on horizontal line, you just mark over here. Here also on right side, you just mark over here. Now you just draw a construction line passing through this point and from this point also. These lines should be parallel to the edge of a square block. So now measure the distance of hexagon from reference point. Let us take, I got a corner point 1 here. I'll measure this much of distance. So for edge 1, I will go for A, B, C, D, E, F. What I done now? I took a distance of 1A. Now from this corner point, I'm just going to mark here. I got a A point. Okay. I got a point. And similarly, I'm going to mark over here because the distance remains same. The distance remains the same as you are drawing an equal size hexagon. Okay. Now you got a point A, you got a point B, you got a point C, you got a point D, you got a point E, and you got a point F. Now this is what a corner point 1, this is corner point 2, this one is corner point 3, this one is corner point 4. Now let us join all these points initially with a thin line. Now this is what hexagon base. Now height of the pyramid is 60 mm. Now from this center point, you just mark 6 blocks. One 1.5, 2.5, 3.5, 4.5, 5.5. Let us mark here 1, 2, 3, 4, 5, and 6. Now just to draw a thin line here, or you can draw its axis. Okay. Now this point is what affects of the pyramid. Okay. So now connect base point of hexagonal pyramid with a very thin line. Okay. Now where you got a visible edges, you just go for dark line. Go for a dark line. Okay. Now this completes the solution of this first problem. So let us see how we can solve this problem using solid edge. So let us draw first one horizontal line, then you draw one vertical line. So now from intersection point of this horizontal and vertical line. We just start a right side edge. It is of a length 70, angle is 30. So I will go for vertical edge. That is length 20, angle is 90. So I will draw one more top surface edge. Distance is 70, angle is minus 150. And here I will go for distance as 70, angle as 150. Now I will come down, distance as 20, angle as minus 90. So let us complete this one. Okay. So once you done it, then you use modify option. Here we will go for a move option here. So turn on copy, select this top edge. So place a end point as a reference, place over here. Similarly, select this as an edge, select here end point as a reference, then you place over here. Similarly, as you need to go for placement of the midpoint, so what I'll do, I'll go for a thin line, again 0.13. I'll go for move with copy option. I'll select this edge. I'll keep end point as a reference, and you just move your cursor over here. It is going to snap the midpoint. You just place over here. Again, select this edge. Okay, keep this end point as a reference. Slowly move over this line. You are going to get a midpoint. Snap over there. Now you got a top surface midpoint. Now you got a top surface midpoint. Now let us construct hexagon here. So it is a 20, 0, 20, 60, 20, 120, 20, 180, 20, 240. Then I am going to close here. Okay. So now next construct a rectangle. So covering all the edges, corner points of this hexagon. Now you just measure the distance. So from this end point, that is a 10 mm. Is it a 40 mm? Over length here it is a 40 mm. Okay. So edge distance is 20 mm. So now I am drawing the entire drawing as per scale, and finally I am going to reduce it to 0.8163 times. So you are going to get isometric projection. Okay. Now let us mark its midpoint. Okay. Now you just measure the distance. I think you are going to get a 20 mm here. So now from this line, just change the line color type. So from this midpoint, I'll just draw a line of 20 mm. Okay, of 150 minus 150 angle. Okay, now here I am going to draw a distance of, let us go for some distance here. Okay, similarly draw a line from this midpoint at a distance of 20 mm, angle of 30 mm. Now you just draw some line length here, minus 30. Okay. Now what I'll do, so you need to measure this distance, how much distance you got here. Again I will measure the distance from this point to this point. It is 17.32. Okay. Just close here, draw a line. So from this midpoint, it is 17.32. So angle is 150. Just a draw line. So it is a 20 minus 150. Okay. Similarly, we just draw on this side, right side from midpoint. So distance is 17.32. Angle is minus 30. Now here minus 150. Now just extend the lines here. Just extend the lines using extend option. Now trim out unwanted portion here. Trim out unwanted portion. Now you got a corner edges here. You got this corner edge here and here. Now let us measure the distance of 10 mm from the center line. Okay. And we just measure from this midpoint. It is a 10 mm. We join here. Similarly, from this midpoint you measure distance of, actually this becomes a little bit what I can say, confusion. So you can go for using offset command, because offset command may not give proper dimensions sometimes, okay, for inclined lines. So let us try with the offset command itself. I'm going to erase this dimension method. Let us see what is the result we are going to get. Okay, offset distance is 20. Select this line and I will place over here. We'll check whether we got as dimensions as the same or not. Let us extend. We'll try once again. So we got wrong here. Let us draw with the dimensions. Or else you can just cross check placing a line from midpoint. Is giving it 22. Okay, so that is what I said. So we get little bit changing distance for offset. Okay. Now this is the case. You can just move over here. You can delete. You can use copy option. Can place midpoint and place over here. Okay. Similarly, you can draw one more line from this midpoint at a distance of 20 mm. Angle is 30 again is same. So you can copy it, okay. Move, copy, and select this line. I'll keep endpoint as a reference point and I'll move over here. Similarly on another side, it is a 17.32, angle as 150. Again here it is 17.32, angle as minus 30. again go for move with copy option. So I will select this edge. I will keep a midpoint or endpoint as a reference. Okay. Now you got a rectangular box. But remove unwanted portion here. Okay. Now measure the distance. So from this corner point to this point you are going to get a 10 mm. Okay. I already got a corner points, this corner point and this corner point. So let us go for a zoom. Okay. So from this midpoint, let us draw 10 mm. Okay. Minus 150 angle. Connect over here. Similarly, from this end point, you just draw 10 mm. Minus 150 or 20 mm. Just delete it. On this side also you just draw half distance. There is a 10 mm and you connect over here, and from this side you just draw 10 mm, an angle of 30 degree, and then you connect over here. So now you got a center point. From this center point you just draw what is the height of the pyramid. Its height is 60 mm. Let us draw 60 mm. Let us draw 60 mm. Okay. You got a midpoint. Got a midpoint. So now connect all this edge point of this hexagonal pyramid to apex point. Now the thing is that you need to observe which are the visible lines and which are the hidden lines. Okay? So let us denote hidden lines here. We can erase. You can keep these construction line as it is with a minimum thickness of 0.13. Okay? So the edges which are clearly visible, we can go for just thickening them. Or else you can keep the edges with a thin line, hidden edges as a thin line, okay, and edges which are clearly visible, you can go with them as a thicker line. This edge is visible, this edge is visible, these two edges are visible, and this edge is visible, this edge is visible. Let us go for 0.5 thickness. Okay. And here also this edge, this edge, this edge. So wedge is missing, let us join here. Proper. Now actually I have drawn up to scale. That is what we have completed this drawing as an isometric drawing. So but It is to be done as an isometric projection. What I'll do, we'll go for scale option here. I will select this entire drawing. I'll keep this as a base point, and I will go for scale factor as 0.8163. Now this completes the drawing.